Good morning. Welcome to the 6th lecture on economics, management and entrepreneurship. In the last 5 lectures, we had covered basics of microeconomics theory. Today, we shall discuss certain exercises on those theories that we had developed in the last 5 classes, and it will hopefully give you much more insights into the real life applications of the basic microeconomic theory that we had discussed in the last 5 lectures. I have covered 2 or 3 exercises from relevant to each of the lectures, as you will see. The first exercise that I take is from the demand, supply and market equilibrium lecture. This is a problem on a demand function for TV sets is given as Q equals minus 2000 P plus 1000 Y plus 0.01 pop, where P is the price of a TV set, Y is the disposable income of a person in a year, and pop is population. This expression is developed on the basis of past data, and it is assumed that this equation defines the demand function for TV sets. 3 questions are asked. Find the demand function and plot the demand curve for TV in a year if the disposable income Y is 16,000 rupees per year per person and pop is 900 million persons. That means, Y and pop values are given, and we are required to find out a relationship containing Q with P. The second part of the question is, if the price of a TV set is 10,000 rupees per set, find the quantity demanded. The third part is population remaining same, the disposable income is 11,000 rupees per year per person instead of 16,000 which was given here. Suppose that it comes down to 11,000, then plot the demand curve. So, first thing is that we are starting with this particular equation, something like regression equation, where a demand function for Q is given as a function of P, Y and pop, and we are required to find out a relationship containing Q with P. For Q with P, given the values of Y and pop, it is straightforward. What we do to solve the first part of the problem, firstly these are given, this equation is given and these are the initial values given. The first part of the question is find a relationship between Q and P. So, if I put values of Y here and of pop here, then I get a constant which is 25 million. So, Q is equal to minus 2000 P plus 25 million, and P thus is equal to 12,500 minus 0.005 Q. So, if I plot P against Q, it will have a negative slope equal to minus 0.0005. That is what I have shown here, minus 0.005. The intercept is 12,500. So, this is 12,500 and the slope is minus 0.0005. The second part of the question is or was that if P is equal to 10,000, then what is the value of Q? P, we know the relationship between Q and P, Q is equal to this. So, if the value of P is given as equal to 10,000, the estimated value of Q is 10,000 into minus 2,000, that is minus 20,000. When we subtract that from 25, this becomes 20 million, and we subtract that from 25, it gives us 5 million TV sets. So, that is the second part of the question. The third part of the question is, if instead of Y, which is given as 16,000 rupees per year per person, suppose that the disposable income reduces from 16,000 to 11,000, population remaining same, then what is the demand function and what is the demand, plot the demand curve. So, what we need to do is just put the value of Y as equal to 11,000 and not 16,000, and put pop equal to 900 million as it was. So, that gives us a value, Q equals, the coefficient of P does not change, only the constant changes. It was earlier 25 million, now it has become 20 million. So, intercept, so P is equal to 10,000 minus this. So, the coefficient of Q is minus 0.0005, here also it remains the same, only the intercepts change. From 12,500 it has come down to 10,000, which means that for this reduced disposable income, the demand curve is a straight line which is parallel to the original line. This is the original line for Y equal to 16,000, pop equal to 900 million persons. So, this is shifted to the left, the slope of this line remaining the same as 0.0005 negative. This is the first question. Now, we come to exercise 2. Now, this is an example where an earlier study has indicated that the supply function for TV sets is given as a function of price of the TV set, price of a competing product such as a music set, then the labor cost, that is price of labor, and the import duty or tariff on imported TV set. So, these are defined here, PC, PL and tariff, and this is the estimated regression equation that relates Q with P, PC, PL and T. Three parts of the question are given here. The first part is find the supply function and plot the supply curve for TV in a year when values of PC, PL and T are given. If the price of TV set is 10,000 rupees, find the quantity supplied, other values remaining same. If the value of T changes from the earlier value of 2,000 rupees to a new value 1,000 rupees, then how will the supply function change? Now, let us take up this particular exercise. So, given the equation, regression equation containing Q, P, PC, PL and T, values of PC, PL and T are given. Now, when I put these values here, for PC 8,000, for PL 80,000, for T 2,000, I get a relationship containing Q between Q and P, such as this. From here I can find P, which is 7500 plus 0.005 Q. So, the intercept is 7500 and the slope of this line is 0.0005. So, I plot this one here. This curve is the supply curve having a positive slope whose value is equal to 0.0005, and if P is equal to 10,000, if P is equal to 10,000, the value of Q is given as 10,000 into 2000, that makes it 20 million minus 15 million. So, that gives 5 million sets. Now, the third part of the question is, if other values remain same, but only T changes from the given value of 2000 to 1000, then how will the relationship between Q and P changes? The demand curve will have an equation. You put the values here, T equals 1000. So, Q becomes 2000 P minus 13,000, 13,500,000, and from here I can find P. The intercept is 6750 corresponding to the point here 6750, and the slope is exactly same, positive and the value both are same. So, this line is parallel, but the intercept being lower than the previous value, it means that as T is reduced, it shifts to the right. So, this is the exercise 2. Now, we go to exercise 3. Here we are trying to find out the equilibrium value. Now, there are two ways. One is plotting graphically. This is our demand curve with a negative slope. This is our supply curve, that has a positive slope. The point of intersection gives the equilibrium value of price and output. In this case, the value is obtained as 10,000 rupees per set, and this is 5 million TV sets in a year. Analytically also one can find this value, plot find the demand function that we have already generated, which is minus 2000 P plus 25 million, and supply function we have already found out, Q equals 2000 P minus 15 million. So, equate them at the equilibrium point or at equilibrium, and we will get this equal to this, and that will give us a value of Q and P, the equilibrium values of 10,000 for price and 5 million TV sets as the output or the quantity. This is exercise 3. Now, we come to exercise 4. In this example, this exercise, we are given price and output for a particular product in these two columns, quantity and price, and we are required to find out the total revenue, marginal revenue and average revenue. Now, total revenue is nothing but Q into P. This is also known as sales or total sales or sales revenue or total revenue. It is just the total amount obtained by selling this amount of this quantity of goods. So, nothing is sold. So, the revenue is 0, total revenue is 0, 1 at a price of 75. Therefore, the revenue is 75 into 1, 75. Suppose the price is 70, quantity is 2. So, it is 140. If 3, it is 65. These are given. So, just multiply So, product of Q and P is basically equal to TR, and it is found out. This column gives the total revenue for this quantity sold. Now, marginal revenue is if quantity increases by 1, then what is the incremental revenue? So, from 0 to 1 the increment is 75, 75 minus 0 is 75. From 1 to 2 total revenue increases from 75 rupees to 140 rupees. So, the increment in total revenue is 140 minus 75, which is equal to 65. Similarly, from quantity 2 to 3 the total revenue increases from 140 to 195, giving an increment of 55. That is the marginal revenue. So, marginal revenue is calculated in this manner, and you will see that marginal revenue reduces and becomes negative and even more negative as quantity increases and price reduces. Now, average revenue is nothing but total revenue divided by quantity, and in this case it is same as price. Of course, 75 divided by 1 is 75. This AR cannot be found out. I am sorry, this should not have been a 0 there, it should be a hyphen here, because 0 divided by 0 is nothing. 75 by 1 is 75, 65 by 140 by 2, 140 by 2 is 70, 195 by 3 is 65, 240 divided by 4 is 60, 275 by 5 is 55. So, basically this quantity, this average revenue is same as price excepting for the first one. So, this is how we find out total revenue, marginal revenue and average revenue. Now, we come to our next exercise, and this says assume that a company with the name ABC Electronics has the following total revenue and total cost functions. So, total revenue function is given in this fashion, and total cost is given in this fashion, and where Q is the quantity produced. Find the profit function and hence find the optimum output that maximizes the profit. Now that we know total revenue and total cost, we can find a profit function and we can optimize the profit. We can find out the value of Q that maximizes the profit. That is what is the first part of the question. The second part of the question is show that the profit is maximum when the marginal revenue is equal to marginal cost. So, this is exercise 5. We go with the solution in this fashion. Define first of all that the profit function pi is given by the difference between the total revenue and the total cost. So, total revenue minus total cost is the total profit made, and then we find out profit function, and then we differentiate that profit function with respect to Q to find out the optimum value of Q that maximizes profit. So, what we do here, this is pi, the profit function is total revenue minus total cost. So, you subtract, when we subtract the two we get this, that is 1000 minus 1500 plus 110 Q minus Q square. So, this is a function of Q. So, take the first derivative d pi dq we get 110 minus 2q, put that equal to 0. So, this is the necessary condition for a function to be maximum or minimum. The first derivative must be equal to 0, and that gives a value of q equal to 55. To find out whether this value of q minimizes or maximizes pi, we go to the second derivative. Second derivative is minus 2, which is less than 0. It means that at this value of q, pi must be maximum. So, the first part of the question, which is find the profit function, it is subtracting TR, subtracting TC from TR, which is this, and the optimum value of q that maximizes profit is 55. We have tested that it gives the maximum value. The second part of the question was that show that at that optimum point MR is equal to MC. It is very straightforward. Pi is equal to profit is equal to total revenue minus total cost, which is written here. If I take the first derivative with respect to q, which I have done here, that is nothing but first derivative of TR minus first derivative of TC. The first derivative of TR with respect to q is nothing but MR, and the first derivative of TC with respect to q is nothing but marginal cost. And since d pi dq has to be equal to 0, when it is maximum, MR must be equal to MC. So, it is very straightforward. This is the second part of this exercise. To exercise 6, this exercise deals with arc elasticity. Now, if you read this exercise, during February, in an effort to reduce the end of the year inventory, an auto brake assembly manufacturer offered rupees 6,000 discount from the existing rupees 60,000 sticker price on each brake assembly. The monthly sale rose from 15 to 23 on account of this price discount. Now, you see that the change is something like 10%, which is higher than 5%, and if you recall, whenever there is a price change of more than 5%, we go for computing the arc elasticity of demand. So, the question therefore is given is to calculate the arc elasticity for this brake assembly, and the second part is quite interesting. It says calculate the sticker price reduction necessary to eliminate the manufacturer's remaining inventory of 27 assemblies during the next month. Come to the solution part. This is the diagram that shows the situation. Now, this is the demand function for the auto brake assembly. Now, the operating point is here, that initially the price was 60,000 and the quantity demanded in the market was just 15, and the manufacturer reduced the price by giving a discount of 6,000 rupees, bringing down the price from 60,000 to 54,000, and that resulted in an increase in the value of Q2. Now, this reduction is, as you can see, is 10%, quite high. Therefore, arc elasticity calculation is relevant here rather than point elasticity calculation, and according to our equation for arc elasticity, it is the change by the average, change in the quantity by the average quantity divided by change in the price by the average price. which results in this expression Q 2 minus Q 1 divided by P 2 minus P 1 and P 2 plus P 1 divided by Q 2 plus Q 1. This division by 2 cancels out. So, we have price elasticity of demand, that is arc elasticity is given by this expression. Now, put the values of Q 2, Q 1, P 2, P 1, P 2, P 1 etcetera, and we get a value of arc elasticity as equal to minus 4. Now, the second part of the question is that at the end of the month there are 27 brake assemblies available. If the arc elasticity is minus 4, then what should be the price at which it can be sold, so that all the 27 can be sold out. That means, if this Q 3 is 27, what is the value of P 3? So, we use the same relationship, excepting that instead of P 2 we now write, we do not take the old value of P 2, this actually is P 3. So, instead of P 2 it should be P 3, P 3, P 3 and P 3 and P 3. These changes should be done. So, I am just putting these values here. So, this expression gives a value of P 3 is equal to 52,000, P 3 minus P 1 is equal to minus 8,000. That means, a further discount of 8,000 rupees per brake assembly should be given, and that will enable the manufacturer to sell out its remaining 27 inventory brake assemblies. So, this is example 6 or exercise 6. Now, we go to exercise 7. Exercise 7 is likewise quite interesting. It says that video station sells video recordings of movies and also sells blank cassettes for home recording. Now, during Puja holidays, video station reduced its prices as follows. For video recording, it reduced its price from rupees 29.99 to rupees 24.97, and for blank cassettes, it reduced its price from rupees 19.99 to rupees 14.97. The trade association in a recent study has estimated the point price elasticity to be as follows. For video recording, it has found out a value of minus 1.5, and for blank cassettes, it found out a value of minus 4. Now, in the light of these trade associations recommendations or estimated values of the point elasticities, are the new prices justified? Meaning, these prices that the video station is now charging, is it justified? If the unit cost of manufacturing, that is unit cost of preparing a video recording and having a blank cassette, are rupees 10 and rupees 8 respectively. This is the question, is it justified? Now, recall the relationship between the marginal revenue, price and point elasticity, point price elasticity epsilon p. Marginal revenue is equal to DDQ of TR, that is unit change in Q brings in how much change in the revenue, total revenue. Total revenue is nothing but price into quantity PQ, and as we know P is a function of Q. So, if you take the derivative, it is first function as it is into the derivative of the second. So, P multiplication derivative of the second means dq which is 1 plus derivative of the first function which is dp dq multiplication q. So, MR is equal to this, which is equal to P 1 plus I dp dq I keep it like this, and here it is q by p. Q by p is take p here and q here. So, it becomes dp by p dq by q, and this is nothing but p taken outside 1 plus 1 divided by dq by q divided by dp by p, and this by definition is the point price elasticity of demand. That means, a small change in P, a fractional change in P gives rise to how much fractional change in Q, that is epsilon P. So, the relationship between marginal revenue, price and elasticity are these things. Now, at the equilibrium, as we already have seen, marginal revenue is equal to marginal cost. Hence, the equilibrium prices at which this relationship will hold are the following. As you know, marginal cost for video recording is given as ₹10, that will be equal to price of video recording multiplication 1 plus 1 by epsilon p. So, 1 plus 1 divided by minus 1.5, the value that the trade association has estimated. Now, if I solve this equation, I get a value of price for video recording which is 30 rupees, whereas the new prices that the company is charging is only 24.97. That means, this reduction is not justified. Now, we go for the blank assets. Blank assets, the marginal cost for the company for blank asset is ₹8. Using the same relationship with the new value of epsilon p as estimated by the trade association, which is equal to -4, the value of the blank asset should be, the price should be set at 10.67. Therefore, setting ₹8 is the price, setting the price as ₹14.97 is also not justified. It should be reduced to 10.67, whereas for video recording it should be increased to ₹30. So, the new prices that the company is charging are not justified. Now, you can see from this example that elasticity, knowing the value of elasticity helps in fixing the prices. Now, we go to the next example, next exercise. This exercise is on demand estimation and demand forecasting. We start with a very simple example where we show that the annual sales, the exercise is like this: annual sales of Babu restaurant are as follows in 1000 rupees. Starting from annual sales. So, some year, let us say 2000, this is 2001, 2002, like that up to 2011, and 284,000 rupees, 266, etc. follows like this, and we are required to find out the annual rate of growth assuming a constant growth rate with annual compounding. Make a 5-year forecast. So, basically we are assuming here that the growth of cell quantity sold at time t follows a power function, follows a growth such as this q 0 into 1 plus g to the power t. Q 0 is the cell in the year 2000 and g is the annual growth rate and to the power t. So, this is the annual growth rate. That means, in the starting from 2001 cell is expected to be 2000 cell into 1 plus g, 2002 cell will be 2000 cell into 1 plus g to the power 2, so on and so forth. So, from here suppose that we put the 2011 value as 568 and 2000 figure as 284 and t is 10, then this is the relationship. From here we get 2 is equal to 1 plus g to the power 10. Therefore, ln 2 is equal to 10 ln 1 plus g. There is a mistake here, there should be 10 ln 1 plus g and that gives a value g is equal to 0.0718. So, this is the annual growth rate, that is 7.18%. And suppose that we are asked to find out or estimate 5-year hence forecast of the annual sales of Babu restaurant, then it will be given as Q 15 284 into 1 plus g is 0.0718 to the power 15 and that is 803.436 thousand rupees. So, this is a very simple example of sales forecast where the at any time the cell Q t is defined as an annual growth, compounded annual growth function. Now, we take another exercise on demand forecasting, another simple example. The operations manager of a TV set manufacturing company believes that sales of its products in any month S t increase by the same percentage as income I t during the previous year. Write an equation for sales forecast. This month sales totaled rupees 500,000, while family disposable income increased from rupees 25,000 to rupees 26,000. Forecast the next year's sales. So, the first part of the question is write an equation for sales forecast. The problem statement says that the operation manager believes that the sales of its products in month S t increases by the same percentage as income I t. So, we shall write S t plus 1 as equal to S t plus the change in S. The change in S as mentioned here is some fraction of S t and that some fraction is nothing but as income percentage change. The income percentage change is I t minus 1 divided by I t minus 1. This is the fractional change, which is same for S t. So, the expression u is the noise or the random error. So, S t plus 1 is S t plus S t into this fraction, which is same as. Now, the next part of the question is, if the values are given, you just put the values here. We put 500,000 is the S t, which is taken outside. So, it is 1 plus 26,000 and it increased from 25 to 26. So, 26 minus 25 divided by 25 and that resulted in a value of 520,000 rupees, that is the next year's sales. So, today we have seen some applications, some exercises on basic microeconomic theory and also on demand forecasts. In the next lecture, we shall take some more exercises on production and then we switch over to cost benefit analysis, break even analysis, and further in our forthcoming lectures, next few lectures we shall study various aspects of costing, accounting and engineering economy. Thank you very much.